Good morning, everyone. I'm Matthew Travis, CEO of Phoenix Launch Systems Incorporated, and I'll tell you a little bit about our vision for the future of space commerce. We see that space launch should be a readily accessible marketplace with a life cycle to launch of less than 1 month compared to the 3 to 5 years as we have currently. This is going to require a high launch cadence, responsive access with rapid turnaround and launch on demand capabilities. So the problem today is that large launch systems require large spacecraft. They fly with a single primary payload and require a long lead time. This is true even for the small launchers that are out there and in development today. Also, launch involves a tremendous amount of infrastructure, which drives up your costs, which then translates to the customer price, and that's a big disadvantage for the small satellite community. So, Phoenix Launch Systems was founded by former members from Aphelion Orbitals Incorporated, and our goal is to capitalize on past groundbreaking research and development to realize our vision of operating the lowest cost dedicated nanosatellite launcher. Our solution is to scale down the vehicle, creating a dedicated nanosatellite launch system that has the marketing capability to launch on demand at low cost with high frequency. Our standard payload is 22 kilograms at a launch price of $750,000 to low Earth orbit. Now, I know I skipped over that rather quickly. The key to our business, however, is bootstrapping our early growth. So we have CubeSat components that we also offer along with our complete launch solution, because we offer a turnkey solution to the customer. They provide the payload, we provide the spacecraft and the launch for them. We realize that these hardware components, as well as software, things like our avionics as well, will be ready for market before the launch service is available. So we will put those on the market to generate sales earlier on to help sustain our business overhead while the investment dollars sustain our research and development. So the CubeSat components do represent our MVP in this case. So the customer base is pretty broad. There are estimates of 2,800 or more nanosatellites and microsatellites requiring launch over the next 5 years. We're going to target those who are not suited toward rideshare or ISS deployment. So that's going to be a lot of Earth observation missions, communications, IoT, as well as research missions from government and academia. Now, our baseline is 50 launches per year. This will give us a good profit and enable us to grow. However, our systems are being designed to be scalable up to 200 launches per year. That is an aspirational goal, and reaching that point, we would consider ourselves fully built out at that point. And if you look at our competitors, here are some of them on this chart, you will see that we do offer the lowest launch price for the payload class, and we are dedicated to nanosatellites only. We are not letting our system grow and grow and grow, to ever larger spacecraft. And we do also treat every payload as a first-class citizen. So in order to scale up our operations eventually to 200 launches, we will need to have a reusable first stage, and additionally, we will produce our vehicles on an assembly line separate from our launch contracts. Right now, a vehicle is produced when there's a launch contract, basically. We will produce the vehicles, and we will get our launch contracts. So we'll have a fleet of vehicles completely self-contained and mobile, and they will be able to launch from any spaceport in the world on short notice once we scale up the number of mobile launchers that we build. We already have built, tested, and proven core technology, including propulsion system. As you can see in our photos here, there's our engine test last November. That's a 10 kilonewton engine. We use 6 to 8 of them in our first stage and 1 in the second. And we are currently focused on development of our autonomous flight safety system and our avionics, because we see those, in the technical aspect, those we view are the long poles in our program right now. So our team, I'm the former CEO of Aphelion Orbitals, currently also president of Vogue Aerospace and Defense and executive director of the nonprofit Ares Institute. Michael Ressa is the CEO of Vogue Aerospace and Defense, and he is being onboarded to our board of directors as we move along. He'll be joining fully by the end of the year. Valerie Phillips is handling administration down in Florida. Doug Peets is marketing in DC, and we have Lawrence Travis and Company CPA, my father's CPA firm, 40-year-old CPA firm, doing management advisory services for us. And then we have our engineering team of employees and interns who have helped us along the way for the past 2 years. So just a quick brief note on our financial projections. We're looking at breaking even in year 5. We hope to get a Series A round at the end of year 2. So we are raising $1.5 million pre-A right now with an 18-month timeline and a $150K milestone that'll get us a suborbital demo flight as well as enable us to manufacture our flight safety system and our avionics and get those into the certification process. Our seed and internal funding allowed us to mature designs, retire a much technical risk, especially with the propulsion system. So now we're sort of transitioning to where we're looking at the full vehicle integrated design and production. So, that's not bad. I had a half a sentence left.
Thank you, Matthew. I think your plan is ambitious to have the development and launch in less than a month. It's a very exciting opportunity in the future. How would you plan on making sure that you're launching with the cadence you expect? Are you going to have a wait list where you're racking and stacking payloads and you know who's launching next? Or do you expect there might be some lag time in the folks that are getting you their payloads?
Yes, that's one point I neglected to mention in my presentation. The way we're going to sell the launch is we're aiming to do more of like an airline or train ticketing system where a customer will book a launch ahead of time. It can either be short notice or longer lead time depending on the customer and the mission. So the only way that can work is if your launches are already scheduled, which sounds kind of odd for the launch industry. You schedule a launch for a mission, but we're not planning on doing that. We will have regularly scheduled launches that customers will be able to essentially book a ride on. And we realize that some launches may not be fully booked, just like some flights on airlines aren't fully booked today. Some launches might be fully booked and there will be demand in excess of that, and that's where our launch on demand capability will come into play. We will still be able to serve those customers. And I'd like to note that if we do have an anticipated launch that we have excess capacity, we do plan on offering that to academia, college and high school CubeSat projects, and we would offer that, either at cost or free, depending, because otherwise we'll have to just add ballast to the vehicle, and that's kind of dumb.
So 2 questions.
Yes.
Very interesting to do scheduled launches. Obviously that could lead to a lot of efficiencies, but also could lead to a lot of revenue issues.
Yes.
So I guess the first question is, how many commitments do you have now, and how do you perceive getting enough so that you don't have some airline problems where you don't have enough bookings? And then the second is, where are you on the regulatory side of things?
Okay, we don't have any commitments yet, but we have talked with various potential customers in the industry, both university scale. We've talked with some folks at, shouldn't say the name of the university, at, for example, MIT, as well as Singapore University. we'll get commitments hopefully sometime within the next year as our designs, as we reach critical design review, because we also want to take early launch bookings and get deposit payments on that to help offset our costs. And for the capacity issues, this is where the scalability will be advantageous to us, because we'll be able to scale, more launches, but also fewer. So if the demand, down the road doesn't support 200 launches per year, then it may be 150, it may be 100. If the demand increases, because the market's very dynamic right now, we'll be able to scale up. So we'll be able to adjust our operations to help fit the demand that we have out there, we believe.
You showed one of the slides. You showed that you're using ablative cooling on your engines.
That was in our development engine. We did contract with an outside firm last year to assist in our design of the regenerative cooling, and we did complete that and did have a prototype of that produced. Unfortunately, I don't have a photo of it. But yes, for the orbital vehicle, it would be regenerative cooling.
The other question I had is that you're still shown on the website as the COO of Aphelion. Can you explain the divorce that happened there, or?
What happened with Aphelion, our main milestone to our next funding was the propulsion system development. We did complete that process, but we were reaching the end of our runway. So I don't know if you heard about what happened with part-time scientists with their funding delay. We experienced the same kind of issue, but decided not to pursue bankruptcy or other reorganization like that. So instead, some of us have gone off on this direction.
So this might have been in one of the slides you moved over pretty fast.
I apologize.
Oh, no, it's not. No problem. But the 1.5 million seems to be to get to CDR. How much
Correct.
longer will it take for you to start launching for real, and how much more do you expect that will cost?
We anticipate a Series A funding level of around $7 million to get us to initial orbital capability. And then to fully scale out would be dependent on revenue and funding after that.
How long, which year are you expecting to?
Oh, that's in a supplemental slide, but I can just tell you the Series A funding would be at the end of year 2. We would have orbital flight on the outside 2 years later than that, and we're looking for an exit then 5 or 6 years after that. And there was a question about the regulatory. We have previously engaged with the FAA regarding launch licensing, and we're in a launch licensing process last year. So we do have some experience going through all of that process already.
I may have missed it on the presentation. What's your throw weight to LEO?
The fueled weight is 4,100 kilograms. That's the gross liftoff weight. The dry weight is around 1,000 kilograms. And like I mentioned, the baseline payload for us is 22 kilograms to LEO. And those numbers are going to go up and down over the next couple of years, I'm sure.
Thank you.
Thank you.